Good afternoon, everyone. I am Pınar from Akpınar Cyprus University. Today, I would like to present you a previous study that I have done in the university with one of my old master students, who is not here today. He graduated in 2020. So the title is about the performance of recycled concrete aggregates containing concrete exposed to heating cooling cycles. Okay, here's the outline of our study. The topic is about recycled concrete aggregates, and first we should be remembering why it is needed or useful. Recycled concrete aggregates are actually very well known and very widely used all around the world for decades. However, here in Cyprus, still we are not used to employing these recycled concrete aggregates to our new concrete uses. The industry is not really using these kind of waste materials. And here you can see, even with these two photos, you can see the need for using recycled concrete aggregates in North Cyprus as well. The first photo, you're familiar with these quarries that we have on Akpınar mountains. And you don't need to be an expert to see that these quarries are not managed in the best way, in the environmentally friendly way. Even if they are managed in a better way, we know that we cannot use quarry aggregates forever, and natural resources should be preserved. The second photo is also showing us another environmental risk. We are always replacing our buildings because of their completion of service lives, or sometimes just because we want to replace them with a more modern building. So we are demolishing them, and the waste needs to go somewhere. In Cyprus, unfortunately, even the landfills are not done in a controlled way. You can suddenly see some waste in the middle of a field one day. They're just dumped to nature. So recycled concrete aggregates could be a good solution for both issues, for reducing the amount of natural quarry aggregates that we are using, and also for reducing the construction and demolition waste that we are dumping to nature in this case, which should not be done. Okay, so here is recycled concrete aggregate particle photo that we have taken in our laboratory. So the dark part, let me a little bit summarize the issues about recycled concrete aggregates. The dark part is the aggregate, natural aggregate that was used in the old concrete, and surrounding the real aggregate, we have the old mortar from the old concrete. And after crushing the demolished concrete blocks, pieces, we are sieving them and obtaining the particle sizes that we need. And we are using this as the new block, as the new aggregate in the manufacture of new concrete. So, and of course, using this recycled concrete aggregates, we can use them, but we have to be careful about certain issues. One of the issues is that concrete itself is a heterogeneous material. And if you're using recycled concrete aggregates as a replacement to natural aggregates, you're going to have even more heterogeneous material. That is one issue that I will touch. In this study, we are focusing mainly on the thermal expansion differences, or the effect of these different thermal expansions of these different parts of concrete under heating cooling cycles. And why heating cooling cycles could be important. Even in Cyprus, well, we are used to having high temperatures in summer season. You all know, I think that the felt temperature can go easily beyond 45 degrees, sometimes 60 degrees Celsius is recorded in history. However, due to the climate changes, we are also experiencing several days with snow. This year in 2022, we had several days with snow. So we can have like 40, 50 degrees Celsius within seasons. However, this kind of temperature changes for some parts of the world can be even experienced during the day. In desert areas, you can have very high temperatures during the day and quite low temperatures during the night. So these expansions and contractions due to temperature changes is something that we have to look into. And as I said, when you're having the case of concrete mixes having recycled concrete aggregates, the increased heterogeneity of the material needs to be checked. We are expecting that the new mortar in the concrete and the old mortar and the old aggregates that is coming because of recycled concrete aggregates will be behaving in a different way, of course. And we have many studies checking the strength performance of these concretes, but there are quite less studies talking about the heating cooling cycles and thermal expansion differences. Actually, in this study, we're not going to measure the expansion amounts reported, but we are going to try to understand their effects on the cracks, because we're expecting some internal cracks due to these expansions and contractions. So we'll be checking the strength performances after the heating cooling cycles. So we have two types of mixes. One control mix that was made totally with the local quarried aggregates, and the mix 2 was prepared by replacing 50% of the coarse aggregates by recycled concrete aggregates. And we proposed using temperature cycles between ambient and 160 degrees Celsius. And we had three different sets of heating cooling cycles. And we checked compressor and split tensile strength performances at the age of 28 after applying these heating cooling cycles. So we had 0 cycles like control, 3 cycles of heating cooling, and 6 cycles of heating cooling. And we were, in this case, we were recycling our laboratory waste. We used our laboratory samples that were used in certain tests, and we crushed our laboratory samples that were 3 years old, and we made the screening and sealing. We obtained the particles that we wanted, and we just use these recycled concrete aggregates for replacing the coarse particles. We didn't touch to the fine particles. We use natural sand for the particles. The design strength was 30 megapascal for the new concrete, and the cubes that we have crushed for using recycled concrete aggregates were C25. All of them we selected the same strength grade, and we tried to get some strength grade that was lower than our targeted strength. Here's our mix design and heating cooling cycles. Actually, we checked some literature and we tried to do something comparable to the literature. 160 degrees is not something that we will have in real life, perhaps. However, we use this extreme temperature to a little bit accelerate the effects of heating cooling. And duration of the heating period that we employed was 2 hours, and cooling period was 1 hour. And some mechanical tests as well. Of course, the recycled concrete aggregate particles had worse characteristics compared to the natural aggregates. This is something very well expected because they're old concrete, damaged concrete in most of the cases. And since the aggregate particles are having mortar around, coming in the recycled concrete aggregates, this old mortar is usually known to have more porosity, and this more porosity will be causing more absorption characteristics. So here we have first results about compressive strength development at 28 days. Okay, sure. So quickly going, greens are the control set, blues are the particles, samples with the recycled concrete aggregates. We are seeing that with the compressive strength testing, natural samples, control samples, you cannot detect the degradation due to heating cooling very well with compressive strength testing. We will explain why. With the blue ones, we're seeing a decrease when we're increasing the number of thermal cycles of light, using the percentages of drops, compared to the natural aggregate samples, control samples. You don't see much difference. However, if you check the recycled concrete aggregates containing concrete within itself, you might see that 0 cycles and 3 cycles of heat cooling can cause up to 27% strength drop. And here we have the sweet and tensile strength for both mixtures. Here for both mixtures, you can see the strength drop in a better way. This is actually due to the characteristics of compressive strength testing and sweet tensile testing conditions. In some cases, compressive strength testing cannot really show you all the damages and deformations in concrete, since compression can really close the glass. Last slide, John. Okay, so we have seen that perhaps sweet tensile strength testing could be better in this case, where we are expecting internal cracks for understanding the performance differences. I basically summarized the conclusions while I was talking about the results. So main thing is that, of course, recycled concrete aggregates are having more internal cracks that is better detected in sweet tensile testing. Of course, we think that by managing the quantity of recycled concrete aggregates that we are introducing and managing the other concrete design mix parameters, we can still obtain concrete mixes that we can employ in many applications. Yes, I think this is most so much. May I take your John? Stefan Babacar, may I invite you to